Let's talk about what happens when air masses with different characteristics, such as temperature and humidity, meet each other in our atmosphere. Gravity is the only force acting to hold the atmospheric gases in on Earth. Left to their own devices, these gases would try to achieve homeostasis and be at the same pressure everywhere, all even. The main force responsible for preventing homeostasis is unequal distribution of solar energy, which means there are different temperatures everywhere. When these air masses with different temperatures and different humidity levels meet, a boundary forms between them, called a front. In a cold front, a cold air mass meets and displaces a warm air mass. Because the moving cold air is more dense, it moves under the less dense warm air, pushing it up. Cold fronts can move fast, producing thunderstorms, heavy rain, or snow. Cooler weather usually follows a cold front because the warm air is pushed away from the Earth's surface. In a warm front, a warm air mass meets and overrides a cold air mass. The warm, less dense air moves over the cold, denser air. The warm air gradually replaces the cold air. These fronts generally bring drizzly precipitation. After the front passes, weather conditions are clear and warm. In an occluded front, a faster-moving cold air mass overtakes a slower-moving warm air mass and forces the warm air up. The cold air mass then continues advancing until it meets a different cold air mass that is slightly warmer. The cold air mass then forces this air mass to rise. An occluded front has cool temperatures and large amounts of precipitation. In a stationary front, a cold air mass meets a warm air mass, and very little horizontal movement occurs. The weather that we get from this front is similar to that produced by a warm front. The interactions at fronts are predictable. We have learned that the greater the difference between the two air masses, the faster the front will move through. We also know that cold air masses have greater density and that warm air masses can hold more moisture, which means that a warm front will involve more precipitation. Now you try it. What do you think will happen when a maritime tropical air mass moves into an area that was holding a continental polar air mass? With climate change, we are still seeing the same 4 types of fronts. What's different is that the fronts are happening with greater intensity and happening in places that they did not historically appear.